Where did I stop? I did
Just
all the
before
definitions.
we
Yeah,
finish the theory, so let's do the example.
I think we have to do the formula still, isn't it? I think.
Did you do the formula?
I don't think I did any formulas.
No.
No. So let's have a look at that. Okay. Let's see. Did all that. Did all that. We did that example. We did this. And we did the definitions. We did that. We did this. We did this. We did the units.
Yeah, that's
And now onto the formulas. Yeah. Okay, so some of these maybe you already know. The first formula is for the periodic time, and that's equal to 1 over the frequency. So that's our first simple formula. Can you see okay? Yeah. Okay, next formula. The angular velocity omega is 2 pi over t. Okay. Next formula is speed is omega r. Can you see okay? Yeah. Next one is the acceleration of speed squared over r. Ah, Diego, what happened to you?
Oh, I missed the first class.
Oh, Diego.
Sorry.
Okay. And that's the main four formulas. We'll have a look at some examples now. The first one is kind of a physics question. It's, do you have all those? Yeah. A CD spins at 500 RPM. What is the omega? Does anybody know RPM?
revolutions per minute.
Yeah. That's what they use in cars, isn't it? On the gauge, isn't it? Is RPM? Yeah. So 500 RPM. Okay. 500 RPM. That means 500 turns per per
60
minute.
seconds.
Yeah, per 60 seconds. Yeah. So that means 500 over 60 turns per second.
8.3 or
Thank you. Now, what does that 8.33 represent?
period.
Not
No,
quite, yeah.
it's how many every second.
Yeah, so what's that one? Which letter is that? Hmm? It's 8.33 turns per second. What's that one?
Velocity.
Frequency.
Frequency. Frequency is 8.33 hertz. Right? So we want the omega. The omega is 2 pi over t. What's the formula for t? T is 1 over f. So it's 2 pi f. So if we just multiply this answer by 2 pi, we are done. So that means omega is 52.4 radians per second. Okay, write this example down.
Are you checking the order?
The number looks believable. roughly 8 times 6. It's about it's the right scale. The All Blacks did quite well over the weekend, didn't they?
Yeah.
They had a fair victory.
Well, Ireland played terribly too.
They did, yes.
Yeah.
Yes. Okay, you got that example? Yep, next one. Now, you could get this in the exam, but here is more of an exam type of question. A car takes 5 seconds to drive around a roundabout. Now, let's just make sure everybody knows what a roundabout is. Yeah, you know what it is. Do you guys know what a roundabout is? Virginia, do you know what a roundabout is? Let's draw a picture. Harry, do you know what a roundabout is? Okay.
I know the sound roundabout.
There's many roundabouts in Ireland. And the car comes along here, or maybe it could go all the way around. Right? You know these? Yeah. I think these sometimes depend on the country. Or China has these, or they don't use these? See, like some countries you wouldn't see these. I don't know. China has them or doesn't? Yeah. Yeah. European countries obviously do. For you, Zach?
Yeah.
Yeah.
More in the residential areas.
Residential areas, yeah.
Like the big roundabouts, like in Europe, in 3, 4.
Yeah, yeah. They can be a bit difficult sometimes.
Yeah.
So, a car takes 5 seconds to drive around a roundabout of radius 6. How fast is the car travelling? So, here's the roundabout. And the car, I guess, is doing, I don't know why, maybe it needs to do a U-turn or something. It takes 5 seconds to do this. And the radius is 6 meters. And my question is, what is the V? So that's the speed. If you were able to look at the speed of the car inside the dashboard, the speedometer, in meters per second, that's what we're looking for here. So what formula would we need to get the V? I think we could say V equals omega r, right?
Yeah.
But the only problem now is the omega. Well, what formula gives us the omega? 2 pi over t or. Okay, so that's 2 times 3.1415 times 6 over 6 over 5. Alright, that's okay, isn't it? What do we get here? So that's going to be, yeah,
7.54.
meters per second. That's how fast the car is travelling. Okay, write this example down. You got that? Yeah? Yeah? Next one. So, a boy swings a 1 kilogram object around in a vertical circle of radius 2 at a rate of 2 hertz. How fast is the object moving? So, I'll draw the picture here for you. He's spinning this around. Captain America, spinning this around. It's 1 kilogram, although I doubt that that's important. The radius, that's the mass. The radius is 2 meters, and the frequency is 2 hertz. Now, I'll do it in a moment, but I'll let you try it. I am looking for the V again. Well, I think you can get this easily. You got it, answer? V is equal to omega or, yeah. Omega is 2 pi over t, or t is 1 over f, so that's 2 pi f or. So that would be 2 times 3.1415 times 2 times 2. What did you get? About 20, is it? 25.1 12. Well, 0.1 meters per second. Okay, happy with that? Yeah.
So we wouldn't have to state direction.
No, actually, because the v is a speed, technically in the formula. Okay, now a couple more examples to do. A 10,000 kilogram plane is banking. Does anybody know the meaning of this word for a plane? A plane that's banking? Say again? Ah, that's, well, it's, yeah, taxiing. That's taxiing. Banking is something else. Anyone? Yeah, how would you describe it? Like, what's
It's
it?
a sharp turn.
It's like a sharp turn, yeah. So when the plane is flying and then it wants to turn left, we say it banks. So this is basically turning, it's banking. Okay. It takes 1 minute to fly in a circle, radius 1 kilometer. So I can draw you two pictures. The first picture from the top. That's the plane, and it's going around like this.
It's like a fly.
Yeah, that's the plane. The radius is 1 kilometer. It is actually, isn't it? Hold tight, I guess. The mass is 10,000 kilograms. The time is 1 minute. Is that all the info? It is. Now, if you were to look at the plane, like if you were to look at it directly, it would look like this. I'll try and draw it. There's the pilot. There we go. Okay. I'm doing this because it's well, you could look at both pictures. So here you can see there must be a force towards the center, but you can't see the weight of the plane. Whereas if you look at this picture, you can see the plane obviously has a weight. But there's another force on the plane in this picture. What is it? The lift, yeah. Yes, and we'll get to that one in a moment. Which way is the lift pointing?
The lift will be like that.
Yeah, so we'd say it's
On the third, yeah.
perpendicular. This is called the lift. Now what's happening is if you resolve the lift, let's use a different colour, this way and this way. And usually when you measure the banking, I think they measure the angle here. So we'll call that theta. So this is L cos theta and L sin theta. What do we know about L cos theta?
It's equal to the weight
Yeah, why is that?
because it's neither moving up.
It's not going up or down. What is the L sin theta doing?
It's the centrifugal.
It's the force that's making the movement in a circle. It's the centripetal force. So that means in this picture, what is this force here? This is the L sin theta force here. Okay. Now my question is, what is the centripetal force and what is the banking angle? Well, you really need to know what the angle is first to get the L. So my question is to find L and theta. Now I'll do this one, but I want you to try first. The tip here is you can say L cos theta equals W and W equals mg. And you can also say L sine theta, that's F, yes? And F equals MA, and if you look back, I gave you a formula for A,
V squared over
phi squared
R.
over R. Yeah. So this one's a little tricky, but I want you to try it. It's been in the exam a couple of times. It's a hard one. Give it a try. We'll do it in a moment. Just see if you can get it. It's find L sine theta and, well, actually, what do I say precisely?
What is this?
Centripetal force. Find
Outside theta.
find L sine theta
And theta.
and theta. Got it, you think? There you go.
Most of it.
Yeah, no.
So the F equals ma of the acceleration in the circle is
Yeah.
outside theta.
Yeah.
Okay.
Yeah. Okay. Shall we have a look? Yeah. So we know that L cos theta equals mg, which is 10,000 g. But that helps us a little bit, but we don't know L and we don't know theta. But still, it'll be useful later, I'm sure. Well, maybe not, but I think it will be. L sine theta is equal to F. That's it here, F. It's a force that makes it move, makes it accelerate. But its acceleration is, or its movement is in a circle. So we have a special formula for A. So this is 10,000 v squared over r. This is L sine theta. Now, r is okay, because we know what r is. What's r? 1,000. So we can say this is equal to 10 v squared, because you can divide the r into the because the r is 1,000, you know, so, is that okay? Yeah.
You can give V.
Yes, well,
Omega,
I want to, we could work out v,
Omega over R.
I think that would be best to do omega or, which is 2 pi over t, or, isn't it? Because we have the t at 60 and we have the or. Yeah, so what's this actually?
This shouldn't be 60.
The t is 60 and the or is 1,000. Yeah?
So why? Oh, you wrote T. I thought you wrote 1.
Oh no, that's a t,
Yeah.
sorry. What's this v?
104.72.
Possibly. T is 60 and that's 1,000. So 60 over 1,000 is 100 over 6, so it's about 16 times 6. Yeah, that seems about right. Yeah.
104.71. 70.
Now, can you square that answer and multiply it by 10?
Yeah, 10.96.
So L sine theta, you squared it and multiplied by 10? Should be
No,
pretty.
that's the acceleration. Sorry.
Oh,
The force is.
should be pretty big.
I didn't label my stuff. Is it
104.72. Can you square it and multiply it by 10, please? What is it? 104.72 squared.
Oh.
Did you square root it?
Oh.
Multiplied by 10.
Square it and times 10.
Yes.
662.26.
109,662. Okay. So-
What?
3. Well, no, we'll leave it like that. That's L sine theta. Okay? And L cos theta is 10,000 G. What's that? 98,100?
Yeah.
Now, this is nice. This is nice. I have 2 equations. Oh, so I've answered the first question, haven't I? Find the L sine theta. That's the answer to part 1. Now I'm trying to get part 2, which is the theta. Does anybody know what I can do here to get theta? Any ideas?
Is it
Times? Tan. How do I get tan?
Tan inverse.
Yeah, but how do I get it?
It's off.
Yeah. Go on, Regina.
Sine over.
Well, hang on. Let's see what she has to say. Go. Yeah, which is it? Correct, yeah. If you do this over this, sine over cos. So L divided by L, gone. Sine divided by cos, and then 109,000 divided by 98,100. These two divided. 1.12. So now we can get the theta. Now, if you like, you can use degrees for this answer. What is it? You can. Well, it depends if you're using degrees or radians. What did you get?
48.19.
Could be. What did you get?
48.
48. Tan inverse. Yeah, 48.24. So it's quite steep. Yeah. Okay. Tricky. This one's tricky.
So you didn't even use the acceleration actually.
Well, that's only because I kind of. No, I did here. I just, I didn't explicitly say what it was separately. Okay, do you need to write that one down? Okay. Continue? Yeah? Harry, do you need a minute? Is okay, or you need a minute? Are you sure? Okay. Now, one more example. Tough one. Oops. Well, the last one was tough too. A ball rolls inside a sphere of radius 5 meters, forming a circle of radius 4 meters. How fast is the ball going? So, I'll draw the picture. It's hard to draw. Try and draw it in 3 dimensions. A ball rolls inside a sphere of radius 5 meters. And it's hard to draw this in 3 dimensions, but it's rolling inside. Okay, and this radius here, that's 4 meters. Now, the center of the big sphere would be somewhere like here, and that is radius 5 meters. Can you picture what's happening here?
So is the ball diameter 1 meter?
Which one?
Diameter of the ball.
This one? No, it's just like a little point. No diameter. Yeah. Now, let's have a look at this one. I'll let you try it, but I'll get you started with the picture. So if you look at this part, there's the wall, like here, and here's the ball. How many forces are acting here? How many forces? There's the weight, which is mg, because I don't tell you. And then what force is here? What's this force? What's it called? Yeah. There was something. No. Reaction. There we go. Reaction force here. And my question is, I want the V. Yeah. So, again, I'll let you try this one. And my little tip for you is, you might find it helpful to draw a triangle here. That's my little tip for you. See what you can do. The first thing you want to do is, I believe, to resolve this. Okay, so see what you can do. Oh, you all look so confused. Oh, I think I'll just do this one. You all look too confused and sleepy and hungry. Right, so let's have a look here. So I know r sine theta, what should that equal? Mg, the weight, yeah. And r cos theta, the centripetal force, which is ma, which is m v squared over r. Now, this theta here, how big is the hypotenuse? How big is this line? 5. And this line? 4. And so this line? 3. So do we know sine and cos? We do. So what's sine theta? That's 3 over 5 sine theta equals mg. What's cos theta? 4 over 5. And what's the r? What is the radius, this r? Yeah, what do I put here? It's 4. Yeah? So, do I have enough info? I think I do. Oh, sorry, I accidentally wrote the sign here. I shouldn't have. I should have written, what should I have written? Or, yeah, thank you. Sorry. Alright. Or. Right, there's one equation. There's the other equation. What should I do to these? I could divide them again, couldn't I? Yeah? So 3/5 or divided by 4/5 or, what's that? think it'll be 3 over 4. Yeah? Yeah. And then equals m divided by m. So, and then g divided by phi squared over 4. That'd be g4 over v squared, I hope. Now, if you can't quite see that, you can just write it out. It's 3/5 or over 4/5 or equals mg over mv squared over 4. You get this. Yeah? And then a bit of a rearrangement. So you get v squared equals 3 times g, no, sorry, 16g over 3. And we're finished. What's the v? Square root of that.
So why is the radius 4?
Because the ball is spinning.
Well, I've given you the 4 here.
But that's the radius at the end of the ball.
Well, remember I said don't consider this to have any diameter.
The ball.
Yeah. It's like a little marble. You can neglect it. If it's only the size of a marble, you can neglect its radius if it's gone in a circle of like 3 meters, 4 meters, you know.
But if you say the radius of the sphere is fine and the radius of the
No, I said the radius of the circle it's moving in.
the circle it's moving in.
Yeah. It's moving in a circle of radius 4.
Okay.
Yeah, yeah. What's the V here? This is a very hard one now. It's the hardest one.
Yeah, you have to visualize the triangle like you don't.
Yes, yes, yes. Thank you. 7.2. Tricky. Right? Very tricky. Let's get started on the workbook questions. So there's probably a lot of circle questions. Yeah? Yes. Wonderful. That's wonderful. So if you can spend 5 minutes getting a start on them, that would be great. Told you circle was a big lesson.